So I'm going to look here at doing some correlations with the data. I've imported this from Excel. So I've had an Excel spreadsheet, I've imported it into, so I've opened it up into JASP, and this is what it comes up with. What you can see here at the top is it's labelled the 3 columns. And what I've got in this column, the first column, is 100 metre times, and it's done in seconds. Then it's got the bleep test, which is done in levels. And then we've got an agility test, which is done in seconds. Now, it's got a little ruler for the first one, a bar chart for the second one, and a ruler for the third. This is telling me what type of data it's thinking it is. So the first one, it's saying it's scale or interval data, which is true. It's on a measured scale. Bleep test, really it should be interval data. So at the moment it's thinking it's categorical. So I've double clicked on it, and where it says column type, I'm going to change that to scale. And then you see the third column at the bottom is already scale. So now I've got these 3 columns of data. What I need to do, if you can think back to that decision tree, we need to check whether our data meets the 3 assumptions. What I can tell you is that this data collected was from a random group of people, so it's an independent sample, so we can assume it meets the first assumption. The equivariance doesn't matter for correlation data, so the thing that we need to check is it normally distributed? And if we want to compare 2 variables, both the variables have to be normally distributed. So at the moment, I'm just going to look at some descriptives. So if I click on descriptives at the top here, click descriptive statistics, I come up with this. I've got my variables on the left hand side here, and I'm going to put them across into the variables box over on the right hand side. What it's done is automatically on the right hand side started to populate my means, my standard deviations, my minimum and my maximum values. If you click on the left hand side, the bit where it says statistics, you can see we can change what we want in that table in the right. So at the moment it's got valid and missing data, and then it's got mean clicked, standard deviation. We can have whatever we want from this highlighted. So if you wanted quartiles, if you wanted your skewness, your kurtosis, whatever it is that you want, you can add into that table. I want to know this. I want to look at normality, which is the Shapiro-Wilk test. So I'm going to click the Shapiro-Wilk test. So we get a normality value for each of the 3 variables. So now if you look at the table, you can see we've got mean, standard deviation, Shapiro-Wilk, and this is the value that you get for the Shapiro-Wilk test, but what I'm interested in is the p-value underneath it. So for the 100 metre time, it's not significant, which means the data is normally distributed for 100 metre times. The bleep test is significant, which means it's not normally distributed, and the agility test isn't significant, so it is normally distributed. So if you could think back to the decision tree, if I want to look at 2 variables that are normally distributed, I can do a Pearson's correlation. If I've got one variable that's not normally distributed, I have to do the non-parametric test, which is a Spearman correlation. So that's what we're going to do next. So if I look at the top of my screen, I'm going to go to regression this time, click on it, and you can see it comes up with correlation. So I'm going to click on the correlation. Now I'm going to put my 3 variables across onto the variables list. I'm going to click Pearson and Spearman because I need to do both, because I need to remember we've just said that the 100 metre sprint time was normally distributed, the bleep test wasn't, and the agility was. So I'm going to do both of the different tests. What I think is always important to do is to also create your graphs. The graphs gives you an idea of what you're expecting to see from your statistical test, so it helps you understand the test results a little bit better. So if we were to look at the graphs first, here we've got the 100 metre time against the bleep test. The line is quite flat, isn't it? So I'm guessing there's not a significant relationship between the 100 metre sprint time and the bleep test. If I look at the graph on the right, which is 100 metre sprint time versus the agility time, there is a nice relationship going on. according to the graph. We need to do the statistics or understand the values above to check what we're looking at. The graph underneath here is the bleep test versus the agility test. And there does seem to be a little bit of a relationship going on there too. So let's see what the statistics show. So I'm going to scroll back up. So the 100-meter time was normally distributed. So if I look at that against the bleep test, which wasn't normally distributed, I have to look at the Spearman rho. So the Spearman rho value is minus 0.209. And underneath it's got the p-value, 0.196. I can say that there's no relationship between the 100-meter sprint time and the bleep test. Which, if you think about it, the bleep test is looking at VO2 max, so your endurance capability, and the 100-meter time is looking at your anaerobic, your sprint time. So you wouldn't expect there to be a relationship between the two. If I look at the 100-meter time versus the agility test, both of these are normally distributed, so we'd do the Pearson's correlation. So here you can see that the R value is 0.550 and it's significant. So we would say that's probably a moderate positive correlation, significant correlation. So as the 100-meter sprint time increases, the agility sprint time increases. So here you've got the graph at the bottom right there. That's what that's saying. If we want to look at the 100-meter, the agility and the bleep test, you can see this column in the middle there. Remember, the bleep test is not normally distributed, so we've got to look at the Spearman rho. We've got minus 0.450, and it is significant because the p-value is less than 0.05. So we've got a negative correlation there, and that's what you can see in this graph here. That's why it's always good to have your graphs to understand what's going on. But essentially, that's your statistics done. So if you're writing that up in a results section, you need to you need to say it's a significant relationship, you need to say whether it was a positive or negative relationship, and you also need to say if it's a weak, moderate or strong relationship, and you've got to give your R value and the significance value. If it's a Spearman one, you give the rho value and the significance value.